So in this video, we'll discuss the Gay-Lussac-Joule experiment and the Joule-Thomson experiment. So ito yung dalawang experiments on the first law of thermodynamics that differentiates the parameters of the real gases and the ideal gases. So malalaman natin yung difference ng real gas tsaka ideal gas as we go on with these experiments. Okay? So unahin natin yung Gay-Lussac-Joule experiment. So in this experiment, we have this chamber, isolated yung system, naka-enclose siya sa isang container na may thermometer para mabasa natin yung change in temperature. And then we have the gas, okay, that is trapped in one side of the chamber. Tapos may nakaharang na barrier. Okay, tapos all we need to do is to remove that barrier for the gas to expand against vacuum. Okay, so walang laman gas particles yung kabilang side. So we let the gas expand through vacuum. So yung expansion process na yon, i-monitor natin kung merong mag-change na temperature. Okay, so how do we analyze this using the first law of thermodynamics? Okay, so let's see. dW is equal to negative P external dV. So this is work. Okay, since the external pressure is 0, since vacuum ito, okay, work is 0. Also, the system is isolated, so walang exchange of matter and heat, so Q is equal to 0. Also, yung gas nyo ay inert, so walang chemical reactions, so walang change in the number of moles of gas particles na mangyayari. So just what just happened is the gas is expanded adiabatically, okay, into the vacuum or against a vacuum. Walang work and walang heat. So according to the first law of thermodynamics, 0 ang delta unit. Okay? Kasi 0 ang Q and 0 ang W. So how do we account for this change? Okay? Paano natin malalaman or paano natin ma-determine or ma-measure yung change na ito? Kasi meron tayong thermometer and it could show a temperature change. Okay? Kapag may nagbagong temperature, saan natin i-account? Anong parameter ito? So we will be deriving this parameter using a familiar technique from Euler. Okay, so we can write du, okay, as a total derivative that is temperature and volume dependent. So du, which is equal to 0, is equal to the partial derivative of u with respect to the temperature at constant volume dt plus partial derivative of u with respect to the volume at constant temperature dv. Plus, okay, the derivative of u with respect to the change in the number of moles of your system. Since wala namang change in the number of moles, this is 0. Since this is equated to 0, makikita natin na ito yung magiging result. Okay, we can divide both sides by v so that we can determine the change in temperature with respect to the volume at constant internal energy. So it is equal to the ratio of the negative of the derivative of u with respect to the volume at constant temperature, or the Joule expansion parameter pi t, over the derivative of u with respect to temperature at constant volume, or the constant volume heat capacity CV. So this term is the so-called Joule expansion coefficient. Okay, so you can also express this in terms of the Euler's reciprocity relationship. Okay, you can just derive this, okay, by multiplying both sides by the coefficients. So anong implication ng Joule expansion coefficient? So if we undergo, or if the gas undergoes expansion, okay, meron silang change in the distance with each other. So kung ano man yung IMFA, kung ano man yung interaction nila kapag magkakalapit, magbabago yun kapag nag-expand na yung gas. Okay? If the gases are undergoing IMFA or intermolecular forces of attraction, it means that we are viewing those gases as real. Okay? So may pagbabago talaga sa parameters kapag nag-expand siya. Unlike ideal gases na hindi nag-interact, okay, walang mangyayari kapag nag-expand sila. So walang change in the temperature. Okay? Saan ba natin ina-associate yung change in the temperature? So if your gas has a certain IMFA, para mapaghiwalay mo sila, okay, kailangan mo mag-input ng energy or Q. Okay? So, if you need to input energy to remove the IMFA, ibig sabihin, expanding the gas requires energy. This is an endothermic process. So, therefore, okay, the partial derivative of T with respect to V at constant U, if delta V, okay, dV is positive, okay, if, okay, dt is negative, this particular coefficient is negative, okay? Therefore, IMFA is present. And the interaction between the gases are predominantly attractive. IMFA talaga siya. Intermolecular forces of attraction. However, okay, if dt is positive, therefore yung TVU is positive, okay? Interaction is repulsive. Okay? Or yung predominant interaction between the gas particles are repulsive. Kasi kung nagre-repel na sila, mare-relieve yung repulsive forces kapag nag-expand yun. And some of those repulsive interactions will manifest itself as heat. So magkakaroon ka ng heat release as the gases expand. So ibig sabihin, nagre-repel talaga sila kapag maliit yung space. Okay? So that is how you interpret the Joule expansion coefficient. Okay? So, mangyayari lang yung Joule expansion or magkakaroon ka lang ng value ng Joule expansion coefficient if your gas is real. Okay? It doesn't happen if your gas is ideal. Okay? So, next, we have the Joule-Thomson experiment. So, sa Joule-Thomson experiment, ang kailangan lang natin gawin dyan ay ipupush natin yung gas, okay, by pushing this piston sa kabila. Kasi itong chamber na to, makakatawid naman yung gas dyan. So, kapag pinush natin yung piston na to, papunta doon, yung piston sa kabila, magpupush back. Magkakaroon ka ng gas dito sa kabila. Okay? So, ang chamber na to, gas particles lang talaga yung inaalaw niya. Tapos, yung chamber, okay, is adiabatic. So, walang heat, okay, exchange from the system and the surroundings, okay, vice versa. So, yung delta U, okay, ng system ay conserved inside. Okay? Kasi, walang change in the delta U na may kinalaman yung Q, kumbaga. Okay? So, this is just pure work. Okay? So, since Q is 0, delta U plus Q is equal to Q plus W. Q is 0, so therefore delta U is just equal to W. So, i-account natin yung U. Delta U is equal to U right. Yung U nito ay U2 minus U left. Okay? Is U2 minus U1. So, ang minomonitor natin kapag ka-state function ay yung change. Sa work naman, kailangan nating i-add kasi work done yung nandito, work done din yung nandito. Okay? So, i-add natin. Yung total work done is the amount of work exerted by this piston tapos yung amount of work exerted by the gas dun sa piston kaya siya nag-expand. Okay? So, work right plus work left. So, ito naman ay negative P2. So, yung right ay negative P2 kasi ang work, okay, again is negative P dV or in this case, negative P delta V. Okay? So, sa right, P2, negative P2 times V2 minus 0. Okay? Kasi yung initial state niya dito sa left ay 0. Okay? Dito naman sa kabila, negative P1, okay, times 0 na siya dito sa right, okay, minus V1 siya dito sa left. Kasi yung process natin, again, from left to right. Kaya siya, kaya ganito yung delta U. Right minus left. Okay? So, work is negative P2 V2 because of this, plus P1 V1 because of this. Okay? So, equate natin yung delta U tsaka yung work. So, U2 minus U1 is equal to negative P2 V2 plus P1 V1. So, therefore, we have U2 plus P2 V2 is equal to U1 plus P1 V1. So, yung U, or yung change in internal energy, hindi siya conserved kasi magkaiba yung value niya sa left tsaka right. Yung PV or yung work, hindi siya conserved kasi magkaiba siya ng value sa left tsaka sa right. However, yung U plus PV ay pareho sa left tsaka sa right. Kaya equal yung U2 plus P2 V2 sa U1 plus P1 V1. So therefore, U plus PV is conserved in the process. So this particular sum can be accounted as an energy value or an energy function. This energy function is defined as the enthalpy. So H2 is equal to H1. So H2 is equal to U2 plus P2 V2. H1 is equal to U1 plus P1 V1. So this is called enthalpy. So enthalpy is conserved during a Joule-Thomson process. Okay? So, let's take a closer look dun sa enthalpy. Ano ba yung enthalpy? So, derive muna natin. H is equal to U plus PV. Kunin natin yung derivative ng both sides. Okay? DH is equal to DU plus the derivative of the product PV. So, gagawin natin, okay, delete ko muna to. Okay. let du is equal to dq minus pdv according to the first law. So yung du mo magiging dq minus pdv. So pdv plus yung derivative nito, so left d right plus right d left d right plus right d left, pdv plus pdp. So dq minus pdv plus pdv, so this is cancelled, okay, plus vdp. So dH is equal to dq plus vdp. So dq is heat. This is the temperature dependent function, yung q. vdp is a pressure dependent term kasi v times the change in the pressure. Okay? So therefore, H is state function that is dependent on temperature and pressure, or it can be expressed as a function of temperature and pressure based on the first law of thermodynamics. Okay? So at constant pressure, makakancel yung dP na to. At constant pressure, cancel si dP, so dH is equal to dQp. Therefore, we can say that a heat at constant pressure, okay, is enthalpy. So enthalpy is a heat of change at constant pressure. If we take the derivative of both sides with respect to temperature, we will get the heat capacity at constant pressure, or the Cp. This is the amount of heat required per mole of the substance that should be supplied to increase the temperature of the system by 1 degree Celsius, or 1 temperature unit. Okay? So that is for the enthalpy. We can also express enthalpy as a total differential. So enthalpy is partial of H with respect to temperature at constant pressure, dT, plus the partial of H at constant pressure, or partial of H with respect to pressure at constant temperature, dP. We will only add this, okay, if the system is reacting, or there are chemical reactions that are happening in the system, or if the system is open, merong exchange of matter sa system at surroundings. So wala naman ito, okay, since this is a closed system. Okay? So ngayon, since na-establish na natin yung concept ng enthalpy, let's go back to the Joule-Thomson process. Okay? Since enthalpy is conserved, dH is equal to 0. So familiar na naman tayo dito sa Euler's reciprocity relation. Okay? So if we set dH to 0, and H is a function of temperature and pressure, as we see here, okay, HTP, or partial H partial T at constant P dT, plus partial H partial P at constant T dP. Okay, we rearrange to get this. We divide both sides by pressure. Okay, we now get the change in the temperature with respect to pressure at constant enthalpy. This is the Joule-Thomson coefficient, mu Jt. Okay, is equal to the negative of the change in the enthalpy with respect to pressure at constant temperature. This is the Joule-Thomson parameter. Wala tayong abbreviation, or wala tayong symbol for that. This is delta, or partial of H with respect to temperature at constant pressure. This is the constant pressure heat capacity, Cp. Actually, this one, we call this the happy T. Okay? Kasi happy T. Okay? Happy T. So, mas madali siyang tandaan kapag ganun. Okay? So, the Joule-Thomson expansion coefficient also is indicative of real gases. Kasi walang Joule-Thomson coefficients ang ideal gases. An expansion that is by virtue of the Joule-Thomson process is only possible, or magkakaroon lang ng value yung iyong Joule-Thomson coefficient if the particles have interaction, or IMFA. So, what do I mean by that? So, change in temperature with respect to pressure at constant enthalpy. Okay? So, if you change the pressure of the system, so from low pressure, or from high pressure to low pressure, so tayo ng mag-drawing lang tayo ng chamber. Okay? So, high pressure, tapos i-expand natin siya to low pressure. So, para siyang Joule expansion, pero in this case, pressure yung minomonitor natin. Again, kung may interaction sila, mag-iiba rin yung distance nila. Okay? Magkakaroon ng expansion. So, dP is negative. Okay? If the temperature of the system decreases, ibig sabihin nag-absorb sila ng energy as they expand. So, kailangan nila ng energy para ma-suppress yung IMFA. dT is 0, or is negative, or less than 0. Okay? Therefore, yung mu Jt nyo is greater than 0, or positive ang kanyang value. So, ibig sabihin, IMFA, intermolecular forces of attraction. So, IMFA present. Okay? However, since expansion to, dP is still negative. Okay? Negative. If the temperature is positive, ibig sabihin yung repulsive forces to, diba? Yung tulad nung kanina sa Joule expansion. Na-relieve yung repulsive forces, nag-manifest siya as heat. So, yung mu JT nyo is less than 0. So, repulsive forces present. Okay? So, predominantly repulsive yung iyong mga molecules. Kaya yung mu JT niya or yung Joule-Thomson coefficient niya ay less than 0. If mu JT is equal to 0, no interaction. Okay? Wala silang IMFA. They don't care about each other. So, this is ideal. Okay? Ideal gases, okay, exhibit no Joule-Thomson expansion coefficient values. Okay? Ganun din dito. Actually, sa Joule expansion or sa free expansion. If dt is equal to 0, okay, ideal. So, yung EVU is 0 kapag ka ideal gas ang iyong system. Okay? So, balik tayo dito. Okay? That is for the Joule-Thomson expansion and the Joule expansion coefficient. Okay? So, see you next video.